Okay, so welcome back to the session. I hope you had some good discussions in the coffee break. So I'm Jonas Schlenger. I'm a PhD student at the Technical University of Munich, and I'm going to quickly introduce you to the BIM2Twin project. So just a very quick project overview. So as most of the European projects, we had quite a large amount of partners involved in there. And this project has already just ended a couple of months ago. So coming already to the project and its vision. So the idea here is that we have, so to say, a digital twin of the construction phase or of the construction site, which is very much inspired by lean construction principles. So we try to have some feedback loops that foster some learning, and we try to get situational awareness about more or less everything that is going on construction site, so that we can support decision makers and other types of construction personnel in general. So to show you the overall workflow of how we imagined this. So first of all, on the right hand side we have this physical twin, the physical construction site. And through real-time construction monitoring, we collect some data, we process the data, and then the main methodology that we have here is that we, on the one hand side, we have what is called here the project status information, so the information based on the monitoring, and on the other hand side, we have the project intent information, so the construction plans, the BIM models, the schedules, and such things, and we compare them to see if there's like any deviations. And then we use this information to feed this back into the building process, say, okay, maybe we have some delays, maybe have some issues, and now we need to adapt things in order to do it better the next time or to fix them right now. And in this way, we have some sort of feedback loops in different time intervals to make sure that the construction site is going smoothly and that we can adjust to any issues that come up. So now coming more to the data management aspect and more the focus of this workshop here. So the central piece here is the digital twin platform. So in the center we have this data management module. So this is based on a graph database, an RDF database to be more precise. And then we have on the right hand side, we have information that we need to translate and inject into this database. For example, the IFC models, the schedules, and any type of planning information, but also all of the monitoring data that we've collected on the construction site. Then from the top, we have different services, so different use cases, so to say, and they access this platform through the API, and there we could have something like progress monitoring. We have checking of safety control to make sure that construction workers are safe. We have alternative planning, and this could be extended by basically any type of service that makes use of the data as collected and provided by the different construction companies. And then on the bottom we have this dashboard. So this is then the means to show the results that these services managed to figure out to the end user, which might be the construction manager, which might be construction personnel, or someone else that is working on the construction site. So going a bit more into detail about this data management module. So here we've decided to separate this into 3 different layers. So we have data, information, and knowledge. So data basically being all of the sensor data, the images, or point clouds and things like this. And then we have this information layer where we have more, let's say, user-oriented information. We have information from IFC files. We have processed data. And then finally, we have the knowledge layer where we have some KPIs and stuff that we then in the end really show to the end user. And We have here as an overarching system, we have an RDF graph to organize all of this information. That also allows us to connect things across the different layers. And for the data and the knowledge part, these graphs, they act more as a catalog. So, for example, for the data part, we say, okay, there's like a certain sensor. It has collected certain information on a certain date, and then the actual information will be stored in dedicated databases, like a time series database or something else, because these can be very quickly changing things or very large files that we do not want to directly integrate into the graph itself. And in order to structure this graph, we have tried to use existing ontologies as much as possible. For example, the SOSA and SSN ontology for the data part, bottom-BEO for information, but we have also created our own ontology since we saw some missing needs, especially on the representation of different processes. And so this here, digital twin construction ontology, as we call it, this is really much focused on the processes that happen on the construction side. We have different types of processes. And we also, what we do here, which might be a bit controversial, is that we separate the project intent and the status, so the plan and the actual execution, because there might be cases, for example, that in the plan it says, okay, well, there's just one wall, but then in the construction process, there might be, for whatever reason, they constructed into two different parts because they didn't have enough concrete, or because they were running late and didn't have time to do it, and then do it later on. So in this way, we try to keep it separate to make sure, okay, that we can still match things, even though if they do not end up to being like one-to-one relationships. Yes, so to show you kind of like the whole workflow of how this digital twin of the construction site is supposed to be working. So first of all, we take the RFC files from the construction company. We have to do some pre-processing to make sure that the quality is good, that the information that we need is contained. And we also remove unnecessary stuff. So if there's like some HVAC systems that is not relevant for the use cases, we remove it to make sure that it just does not blow up the graph without need. Then we have to do the conversion process, so from IFC to RDF using existing converters. And we've added some extensions to also include geometric information in there to make sure that we can use it, for example, for this like scan-to-BIM approaches. Then basically we had to do the same for the schedule. Here it's a bit tricky because there's like no existing standard for exchanging schedules. So the stuff that we got from the different construction side was in Finnish, Spanish, and other languages, and then structured very differently, and then trying to figure out what's going on, and trying to link this also then to the RFC file is a challenge by itself. So we have developed some methodologies that do at least some semi-automated linking, but still there's some manual steps involved there because just the differences between companies are very, very large. So we've tested this for several pilot sites in Finland, France, and Spain, and basically then also collected monitoring data on the construction sites. So this was mainly based on laser scans, installing cameras, but also for some we had these positioning systems to detect equipment or construction workers, and these were usually our main sources of data that we used then for later steps. And then we had all sorts of use cases in the frame of the project. For example, doing this progress monitoring based on the point clouds. We had some alternative planning, so based on all of the status information, we had simulations going on that try to predict based on several scenarios, okay, how could this construction site go on? How does it change if we increase the amount of workers? Do we manage to catch up with like the delays that we have? And in this way, we had like all sorts of different applications that try to help the construction personnel in various ways. So basically, these services, they connect to the platform through the API. They request information, for example, from the IFC file or from the different monitoring data, and then they do their computations, and then they feed back their information or their knowledge back into the system to make it available to other services and also to the end user. And in the end, this information will then also be shown in this BIM2Twin dashboard. So on the one hand side, you have this 3D viewer where we can give the elements different colors based on the fact if they're already constructed or not, if there's some delays, some defects. But then also we had different KPIs defined based on safety aspects, quality and execution that try to summarize the current status of the construction site. So to come to an end, some learnings and challenges. So I think for us the difficulty is that the different construction companies that we had have a very different way of working. They have different expertise. They have subcontractors for very different parts, and trying to find a methodology that is generic enough to work for all of them is quite tricky. So I think the flexibility aspect is one of the most important ones. But I think that ontologies and semantic web technologies do provide good means to allow for flexibility and to adjust the schema based on different use cases, based on different construction companies and their needs. Yes, so that's it from my side. Thank you very much. Questions, yeah.
Thank you, Jonas. Really nice work. Can I ask what you're using? So you're putting the tasks in a graph format as well, along with the, so you're using the data converter to put the IFC, and for the scheduled data, so that IFC task, let's say, we're using a specific schema or an ontology?
So the issue was that, I mean, usually no one is really using these IFC process things. So the IFC files that we got from the construction companies, they do not include any processes, since usually they have their project management software, which is completely detached from the BIM modeling process. So what we did, so we didn't receive any IFC task or process or something like this. So we got the schedule in Excel spreadsheets, and then we had to somehow figure out what they mean and how they relate to the different elements.
So I understood that they didn't put it in IFC, but when you convert it into your own database in a graph, what class were they? Were these scheduling events, or what is the name? Do you have a schema?
They were part of our new ontology. So in this, yeah, so we had different types of processes, and then we translated them into this new ontology terms, basically.
Okay. Good. And you're keeping all of them in a graph, all the instances
of the processes?
Yes.
Okay.
Thank you. Jonas, in terms of the sister projects, it was, if I recall properly, HBIM, Cogito, and BIMproof. There is any, I know that the project has been finished, but has been any federation of knowledges or trying to generate any, let's say, combination of future, let's say, of ontologies or on this regard?
So we did have some workshops together. But in the end, it felt like still the focus and like the use cases were still a bit different. And so in the end, we didn't put like an effort sitting everyone together, checking the ontologies and seeing, okay, where is like the part that we, where we agree on certain things and terminologies. But I guess that would definitely make sense to do that, to sit together, take time and see, okay, are we able to agree on something, on some ontology that matches all of our purposes? Yeah, I guess that would make sense.
let's see if we can help on that.
Yeah.
Did I see another question in the back?
My question was similar to Kai, so I think it's already answered.
Perfect. Jonas, thank you very much.
Thank you.
Last but not least.
Hi everyone. Hi everyone. Good afternoon. I'm not quite sure whether will fit the bill as being one of the best in the last session, as was said earlier, but we'll see. Apologies, I've got a bit of a cough, so I've got a glass of water here. So I'm going to give a slightly different presentation. I'm going to tell you about some of the digital twin work that I've been working on and leading on in Cardiff. In Cardiff, we've been doing digital twin research for probably kind of 3 or 4 kind of years prior to this year, developing some platforms and using it for various different things. But one of the most interesting things that we've done is, as of January last year, the university's actually launched a digital twin spin-out company, of which I'm seconded to 2 days a week. So I work 3 days a week for the university and then 2 days a week for the spin-out company. What I wanted to just kind of discuss today is a bit about what we're doing in the digital twin space, and then perhaps discuss some of the different sort of challenges you suddenly find when you're working in the commercial and the business sphere, because we've been discussing lots of really complex and important issues today, but I'm amazed at how many times I have to spend an hour on a call with another large company working out with them how they can get a CSV out of their existing system, because they have no idea how it works. So there is still a massive gap between where academia and research is and where the rest of the industry is catching up. And my thing I would say is probably new, agile, small. I say small because small, but agile doesn't normally go along with large organisations, are probably a way to kind of bridge that. So the topics I'm going to go through, I'm going to talk about from university prototype to spin out, because that's kind of our thing. We developed a prototype on one project, rather than doing the classic thing of going, right, new project, let's start again. We made a concerted effort to try and build on top of that. And then we had another project and we built on top of it again. And the thing kept improving, but also kept having massive scope creep. So it was good and it was bad. I'm going to talk a little bit about the underpinning semantics we've used, some of which is nice and aligned with the stuff we've been discussing. Some of it is where the commercial aspects have come in and we've been, oh, hang on, we just need to implement this in 2 weeks. We just need to find something that works. And that's where kind of the ideological tact you might take as an academic researcher kind of has to give away a little bit. The underpinning technology and some of the work that we've been doing since we started. So just to give you a bit of an indication of the size of the company. So we've got our business partner, who's CEO. I'm seconded 2 days a week to the company as Chief Technical Officer. We've got two members of staff seconded 2.5 days a week looking after sort of the AI side. So they're seconded from the university, so they together make up 1 full-time employee. We've got 2 full-time software developers and 1 full-time energy modelling person, because maybe I should have said the focus of the spin-out, because when we're talking in the business sense, and I've learnt this in the last year, you can't have the broad scope that an academic project. We've really focused in on non-domestic energy management for buildings, and we're kind of using the digital twin technology that we've developed, applying it specifically to that use case. So when we did our research, we looked across all these different things. So we looked across energy and carbon reduction from city level down to room level. So at the most macro level, we've done work in districts. So we looked at kind of ports and their use of smart energy districts. We looked at a redevelopment site that had things like schools, an energy centre, offices all working together on a local energy network. And we even looked at something overarching of the city of Cardiff. We also look exclusively at the building level, where we look at individual buildings and try and manage their energy usage. We've also gone into a lot more detail, looking at an individual space level, trying to instrument spaces, and work out how we can actually manage their uses. And for the spin-out, we kind of ended up in the middle, because no one in industry was really interested in the micro level. They can't do the building level, so why would they be interested in the space level, is the kind of feedback we had. Very, very interested in the district level, didn't have any of the technology you needed to do it. The amount of times I said, well, can we do that with you? We haven't got any sensors, we haven't got any models, we haven't got any data. Can you do stuff for us? And I said, well, not really. You need to give us something to work with before we can even start. So we kind of ended up focusing in the middle level. And a couple of slides I'm going to walk through now are really just kind of showing the sort of evolution of the interface. So this is a video. I hope this plays. But this is some of the work we did. So we did a work on a football stadium in Qatar at the time of the World Cup. I'm not going to walk through the interface, but this was our research prototype interface. So as you can see, we went into this particular sports facility. Sorry, it wasn't a sports facility. It was a stadium. It was a sports facility. And we built in all sorts of things there to do with optimization. So we had the ability to invoke an optimization algorithm based on energy models and stuff. So what we essentially did is we used Energy Plus models to build a surrogate AI model which powered a energy optimization algorithm, which produced some suggestions for them. And that was all very good. And the Qatar funders, the research council over there that kind of co-funded it, were very, very pleased, and it brought loads of data in. And it was kind of a complex kind of research interface. You can see there's lots of buttons, lots of things going on. But the only ever use case for this was for us running it for them and them taking the outputs. It wasn't something that was really usable directly by the lay person. This was our digital twin that we worked on with Cardiff City Council. And here what we developed, there we go. Here what we developed was essentially a system to help them manage the energy of their buildings. And they did things like, we did things like alerts. We see we turned one of the buildings there because it's consuming more energy than it is. We also did things with they had schools. So if there's a school consuming a lot of energy during the summer, that would raise an alert and things like this. And you can kind of see the similarity, but yet not. The same sort of interface, different sort of map view for a different sort of scenario. And we're quite pleased because we managed to work with the council to get meter reading data coming over from them automatically. Or so I thought, until about a year after the project stopped, when they admitted they just had one of their technicians manually uploading it to our servers every morning, even though they told us they'd set up this automation. So sometimes the automation people claim isn't as automated as actually you'd think is one of the anecdotes. So when we moved over into thinking of this in a business sense, we took the view to say, actually, buildings lack data. Generally speaking, in the UK, there was a big issue with buildings don't have much data. Until a couple of years ago, the vast majority of buildings didn't have the vast majority of non-domestic buildings didn't have smart meters, because the government only regulated for the installation of smart meters in domestic buildings. Because generally speaking, regulation for things in the UK that affect consumers is a lot tighter than things that affect businesses. So we went to the view to say, we want to build products that people who don't have a lot of data about their building actually can use. So we kind of took the view as we want to be able to see how much useful information we can produce for them without asking them for an awful lot of information in return. What's the minimum level of information we can get from them to still produce something useful? And we've kind of grouped it into two products. So we've got a very low data product that we're looking to launch sometime next year, and we've got our kind of more consultancy service where they might have no data, but that's okay, you can pay us and we'll send our energy modeler out to your site and he'll go around doing a survey, taking measurements and build the models for you, which kind of we needed to do to start building the client base. So over the last couple of years, we over the last kind of year, we've been doing a lot of work. We had a US patent granted for our methodology. A US patent was the only really one we could go for, because across most of Europe and in the UK, any patent that is UK, that is software-based, is actually not a patent. You can't patent something that's software-based. We've done some work with Network Rail, and we've had some investment from some private investors, a group called Carbon 13, and also a grant from the Welsh Government and the UK Government to help us get started. And our approach is really that our digital twin is made up of input from sensors and meters, a model of the building, which is kind of spatial model, so kind of your BIM kind of thing, a visual model, not really needed to provide any data, but customers love a visual model, so we've got a visual model, and we've also got an energy model that underpins it. We want to get into, I heard it mentioned earlier, actuation. We haven't actually found a customer that's advanced enough to be able to allow us to do that yet. We did some tests with it within the university, but we actually haven't been able to deploy it on a customer's site yet because we can't actually find anyone who's sophisticated enough to actually be able to do it. And actually, what we're providing for people is implementable energy optimization scenarios. So we're providing people with energy saving scenarios and things that they can actually implement in their buildings. So these are things like, static things like, maybe you can change your set points. Maybe you can look at your heating and insulation. But we're also providing operational guidance where we've got the level of information. So some of our sites do have sensors in. So we have sensors in spaces tracking lights and tracking motion and tracking temperature. So we've got some optimization algorithms that we're bringing online to enable people to provide kind of more operational responses, like go change your set point of your thing and things like that. We used a bunch of semantic models that were already existent. So we initially built using BOT, SSN. We use a scheduling and model execution ontology. We ended up, for scenarios, data alignment and events, building our own. And when I mean data alignment, I mean essentially we've got a model that essentially models the structure of a CSV, because every single CSV for every single customer has a different structure. They have their dates and times in different formats. They have different orders of columns. Some of them run down, some of them run across. Basic nuts and bolts stuff, but stuff you need to get over. And I think my time is nearly up. So I'll just skip on to showing you some of the interesting stuff that we did. So what we can see here is this is some of the interface that we developed. And one of the things we've made a really big effort to do is try and really clear up our interface, make it really, really simple. That is quite small, unfortunately. So I'll see if we can zoom in. I didn't pick the best screenshots, apologies. So as we can see, one of the things that we've done is we're integrating inputs from models. If we're doing a survey, when our surveyor goes out, he takes 360 photos. We also have a 3D visualization model. We provide users with summaries of their energy consumption that we take from their meter readings. And by running a bunch of energy models with slightly different simulation parameters in the background, that's how we come up with our energy saving scenarios, that we present them to them in a variety of formats. So I know that was a bit quick, and it wasn't heavy on technical details. I can't go into as much technical detail as I can with a piece of academic work, but hopefully that kind of gives people insight that actually you can take a digital twin idea from research and actually get it out there and make some money, or at least attempt to run a business of it. Only time will tell whether we'll actually survive, but that's the case of all startups. So thank you.
I think you don't have to apologize for your presentation being different, because bringing things to end users is exactly what we need, right? It's fun to do the research, but if it doesn't end up being used in practice through commercial companies who are the ones bringing it to practice, there's little point in continuing what we're doing.
And one of the things that we've kind of taken the attitude of is there's kind of I don't know whether this is a UK saying, but they said kind of clever technology should be indistinguishable from magic. And you might have seen on one of the early interfaces, you could put all sorts of things in, like if you got an AI model, you could set the hyperparameters and all. But customers can't do that. They don't want to know about that. They want things as simple as possible. So it's about trying to automate as much as you can and keeping the complexity hidden. So in some ways, you're almost underselling the complexity of what you're doing, but equally, you're delivering a valuable service.
Exactly.
Yeah.
It's the beautiful insight. Any questions in the room?
In terms of simulation, are you using any mathematical model to generate synthetic data to fit up the...
So we're using Energy Plus models. That's the underpinning energy model. So most of our sites have been kind of on our curated kind of scheme, our consultancy. So we'll have an energy modeler who'll go out, he'll do a survey, he'll do an initial calibration of the model against the energy data they've given us. And then what we'll do is we'll execute that model multiple times with a variety of different parameters to come up with the results of our scenarios. So it is all underpinned on energy models. We are working at integrating AI models as well, because one of the flaws with, I say it's a flaw, one of the facts of an energy model is they do take quite a long time to run. It can be 30-40 minutes to run an energy model. So we look at building surrogate models, or actually sometimes if we've got a lot of historic data for a room, but it's very fine grained, like temperature in a room, it might be much more convenient to try and build an AI model of what do we think the temperature in that room is going to be in the future, as opposed to trying to use an energy model for that sort of task. So we're kind of using both.
Thanks.
Thank you, Thomas. During our presentations, I took some notes, like what were the main insights and takeaways for me, and some I already mentioned, I think, or reformulated as a question. Yet I do want to show these to you, share those with you, as a starting point for our discussion. And in the discussion, I invite all of you to just vocalize your opinion and your takeaways of today, and let's see whether we can challenge each other to make even better products and standards and be more effective that way. I do need to download the presentation again because I took some notes during the last sessions too. So the key takeaways, and please presenters, if I completely misunderstood what you intended to share, raise your hand, interrupt, anything, let us know. So first thing, Judith, what my key takeaway was from your presentation is different people need different things. But what we don't yet know, or what you're still researching, is what has already been standardized by people. So what's already out there that we could use to make the things that different people need. So give some insight from the end user or the user perspective, where the user is an expert, but an expert on the domain and not an expert on the technical side of things, or on standardization or ontologies. In DigiChecks, unfortunately, Jeroen had to catch a train. The ontology scope was extremely, or quite limited, and in fact it was required because of geographical and organizational differences between regions. The variety of permitting processes is just too big to basically catch in one ontology or to catch in a set of ontologies. So there's a let's say, a small ontology that's extended on lower levels. And they implemented this in an application that seemed extremely end-user friendly, and to me didn't look like an ontology at all, yet it was based on one. So the focus was on end-user experience, and also through some pieces in the toolkit, there was a focus on developer experience, because we have to get the developers to make the software user-friendly as well as aligned with the ontology. I do know as an inside information that there's also room for improvement there. So lessons learned during DigiChecks, during the development, on how to take developers along in this process. The building ontology, or building energy simulation ontology, as presented by Pablo, again showed that different users have different needs. And I think Callan's question there was perfect, right? Like, do you need so much detail in your ontology on sensors? Oh yeah, Pablo did, but Callan's use case, it's not needed. So there's different scopes and different needs here. And the approach of Pablo so far is to still keep the core small. Even though many different needs are needed, the core is extremely small and therefore it's more manageable. In Hypergrid, one of the important conclusions was that better standardization and a better developer toolkit, pieces of tools for developers to build software with, would have really reduced privacy challenges, but basically the entire process of developing the Hypergrid platform or the Hypergrid software. Different to projects aimed at specific cases or implementing specific ontologies, Alireza presented us the status of the building BDTA ontology catalog, where developers need a catalog to find ontologies within the domain or the use cases of building digital twins. But there are some signals or ideas that maybe users need a similar catalog for applications, or maybe for ontologies also listing the applications that implement them, because the end users, well, they're the ones using your software and not your ontologies. And there's one other thing that's needed, that's Alireza needs your input and your knowledge on ontologies in the field. Because just like we reuse knowledge by others inside our ontologies, knowledge on ontologies also is quite distributed among us. So please help BDTA and Alireza out there to make the catalog complete and include your knowledge. Meta Building Labs, the semantic testing facility, noticed that there were some very specific ontologies lacking. However, the main components were there. So this is an indicator that maybe assembling ontologies together to meet the use case is a viable approach. And the technology stack for applications doesn't necessarily need to be completely semantic web. There was GraphQL was used, time series databases. So dependent on different technical use cases, different technologies are just more suitable, even though they are enriched with a semantic layer or an interoperability layer. The tech stack doesn't need to be a semantic web tech stack from start to end. Last two presentations after the break, BIM to Twin, really again an insight, ontologies, pick and choose from ontologies to meet your use case. There's not one that covers it all. There are some really good ontologies, and it's okay to take some components from each ontology and assemble it together to meet your use case. You don't have to use all of it, you don't have to use one. It can be an assembly, and therefore you are still aligned with others, but improving standardization. And Optimize AI showed that end users are in fact able to use user-friendly software. They shouldn't even need to know about ontologies. The product is a success if the end user doesn't know about ontologies. However, it feels like magic. Things just work, and things just exchange. Information just flows. And now the next question is, so what? What do we do now?
If I may, or let me think it's.
I don't think the online.
Yeah,
It doesn't work, I guess, for the.
I think it's important